Okay, let's go. So where we left off last time is that we were finally able to click stuff, such as a worker here, and then have stuff happening, in this case showing some information about the worker and what the worker is up to. And it was our first step into some form of interactivity, but it's not yet truly interactive because we're still just only viewing the world and viewing what's happening in the simulation. And that's what we want to change for today. So today we're going to add some true interactivity by allowing you to queue up jobs to change styles. That way we can build walls and floors. There is quite some work we need to do so we'll go over them step by step. We need to change our model a bit. We need to change our view model a bit, and of course we need some GUI work to be able to actually show and select stuff we want to build. So let's start by changing our model. Let's just open up Xcode and we'll go through these steps one by one. So here's Xcode. The first thing I want to do is I want to get rid of the job that shows changes in the world. So we're going to get rid of this make rooms job. This way, if we now run the app, the worker is just staying here idly. Okay. So that was the first step. The second step is I want to have a place where we can store some of our constant game data, because here and there we are now creating items as a sort of in place. I think it would be much more convenient if we have a central place where we store these types of data that we recognize in our game. So I'll create a new group called data, and inside we'll create a new Swift file. We'll call this one game content, and this will just have definitions for data, and we will use extensions on data types to create this. So for instance, we have an item here. We'll create a static computed property called wooden blocks, and this will just return a wooden block, a wooden blocks item. That means that we can now, for instance, in our world, replace this one with, we can replace this one with item.woodenblocks. There are some other places probably where we have this, but this is enough for now. We need the wooden blocks because we assume that we need wooden blocks to build walls and floors. So that's one place, the place where we store data. We can add more items or objects or any other stuff we need there later, but this is enough for now. We also need a bit more information about building tiles, because we want to create tile jobs, but some things might differ based on the kind of tile that we're creating. For instance, if we take, we might need some items so to build a tile. So we'll create a computed variable called item requirements. This will return an array of requirements, and based on its own value we will return what kind of tiles we need. So for instance, for the floor we will need a requirement called items, and this takes an item stack, and the item will be the wooden blocks, and this will take one wooden block, and that's all that we need for the floor. For instance, for the wall we will return again an items requirement, an item stack. The item again will be wooden blocks, but this will take this will take 2, and for everything else for now we'll say they don't require anything, so we'll just return an empty array. So this way we can get item requirements out of a specific type of tile we're trying to build. We also might want to vary the build time based on the type of tile we're creating. So we have, let's create a computed variable called build time. Again, it will, depending on its value, return, for instance, for building a floor will take 1 tick, and returning building a wall will return 3 ticks. And for now, again, for any other case, we'll say they don't require any time. So now we have items and build requirements, item requirements and build time defined for our tiles. We can use this to create a helper function that creates tile change jobs. So if you go to our job definition, you can see that we have these convenience functions here that create jobs of a specific type. Let's add one that creates change tile jobs. So let's create a static function called create change tile job, which is basically building a tile. This will take in a tile that we want to create and a position, and this will return a job. And we'll start by collecting all the requirements. We'll start by taking a position requirement, so we always want to be in the place where we are going to build to be able to perform this tile. Then we will add to these requirements the contents of tile.item requirements. So this way we can also get the items requirements into the requirements array. And now finally we can return a new job with the job call of change tile, and this will be set to tile at the target position, and it will have a build time, and this will be the tile.build time. That's why we defined it just yet, and requirements as we collected them in this variable. So we now have a helper function that helps us create change tile jobs. That's not all we need. We also need to have a description for job goals, and the reason why we want to have a description for job goals is that makes it easier to create a nice looking menu later, because then we can use the description as a sort of text to show in our selection menu. So we'll create an extension on the job goal, and this will conform to custom Spring convertible. This means we need to implement a computed variable description, and again we'll switch on our own value, and in case it changed style, then we'll say, then we will return change style to tile.raw value, because that's a string. In case it's fetch items, so this will bring in an item stack, then we will return let's see, we fetch a number of a specific item, and the last one is a move to location, and this will say return move to location, and it Yeah, this is good enough. Move to location. Okay, so that's the job goal description done. Let's see if we need to do anything more for our model. Oh yeah, we need to find create a helper function in the world to find the total amount of an item. And the reason for that is that we want to make sure that we only build stuff that we have enough items for in the world to prevent the workers from deadlocking. Meaning we need to find out whether in the world there is enough of a specific item available. So totaling all the item stacks of a specific item. Let's go to our items management, where we have our get item function and our get location with items. So let's create a new function called item count for an item, and this will return an integer. So we'll first find all the items that match. This will take an item stack in, and then we'll say item stack dot item equals this item. Then we'll say return correct items dot reduce. So that's a bit of functional programming to basically sum up all the values. This takes in a partial result and an item stack, and it returns the result plus the item stack dot amount. And that's it for this function. So let's continue. This should be enough to get our model working correctly, allowing us to start working on the next step. So let's see. So next we're going to add some stuff to the view model, because it's the view model that will need to take some state into the account regarding what we're trying to do and whether we're trying to select. So, but first let's get a computed property that gives us back a set of build job goals, and this will be an array of tuples that contain a job goal, and whether that job goal is available currently. So we can sort of gray out certain options if they're not available. And let's create an array here that takes a change style dot floor, and then a Boolean value, and we'll look into this Boolean value in a bit more. So, and the second one will be a change style to wall. Now let's put it to true as well. So let's see if this is accepted. I'm checking because the autocomplete wasn't really helping me, so that sometimes indicates an error. Let's create a helper function that makes sure we want to make sure we only show jobs that we have the items for in the world. So let's create a private function called can_meet item requirements for a tile, and this will return a Boolean value. So we'll say for requirements in tile.item requirements, we'll switch on the requirement, and if it's an items requirement that has an item stack, then we'll check if our world, the item count, and we want our item stack that item is less than the item stack that amount, then we return false. So if the world has less of a specific item than that we are requesting, then we return false. Also, we're giving it the default value of 0. So for instance, if for one reason or the other world has not yet been set, we assume there are no items in the world. For the default case, we don't do anything, so we break. And if we somehow make it through all the requirements without sending out a false first, then we return true. And now we can change these truths to can meet item requirements for and can meet item requirements for the wall. Okay, so far so good. So we're missing a return field. That probably means I placed this thing in the wrong set of brackets. Okay. So we have our build job goals. These will be the build jobs we can choose from. So we can choose to build either a floor or a wall. What we also need to keep track of is if we have a current job goal, because we can imagine that we first need to select a job goal and then still need to select where we're going to build it. So we need to keep track of the current job goal, the one we're trying to fill in the meantime. So that's why we create a variable called current job goal that we can access later on from the UI. And finally, we want to start working on selections and making sure that once we finish our selection that we do pass in the selection to a current job goal if it has been set. For now we'll make it quite simple, but we'll add to this later on when we implement box selecting. So we'll create a function called finish selection, and we first need to make sure that we have a current job goal. So because if there isn't a current job goal, we can't create a job. And then we return. So then we switch on our current job goal. And in case it's a change style job, that's the one we're implementing here. Then we can see if we have a hover coordinate. We should, but let's be careful. So let's unwrap the hover coordinate, and then we can use that to create a new job. And here we can use our create change style job to the tile that was passed in, and the position will be the hover coordinate. And then we take our world, we take the jobs, and we enqueue this new job. And this is what adds the job to the world, and what eventually will lead to changing the world. For all other cases, for now, we'll print out not supported job. Well, actually, I think we were working with a logger, so we should send out a debug message. This could be, for instance, a warning, and this should be not a debug message. Okay. So this should be it for our view model. So we need to allow it for creating jobs. We can create a function to check whether a job can be finished or not based on the items. We need to keep track of an intended job, that's what we did, and we handle selection of the target location for a job in this finish selection function. Now we're almost ready to bring it all together. Let's start by creating a build menu where you can choose what to build. So let's go into a GUI, add a new file. It'll be a SwiftUI view, and we'll call it a build menu. and the build menu will take in an observed object, the ViewModel, and it will also have some internal state, a submenu state. This way we can use this to dismiss the menu. We're not going to use a boolean for this, but actually we're going to use an enum for this. So let's create this enum real quickly. We have our GUI view. Let's create an enum here called submenu state. This is where we can indicate whether we are in any submenu. So there could be none, but the first one will be our build menu. So now if we go back to our build menu, we can give this a type of GUI.submenu state. And because we're binding it, we can return an updated value of this one. So what will our menu look like? We will create a scroll view. And the scroll view will have a for each loop that takes in our ViewModel build job goals. So we'll go through each build job goal. We need to pass in some form of ID. We'll use the job goal.description because this should be unique. And this brings in a value of type job goal available. This will be the tuple we created earlier. And then for each one we can create a button with an action. And the action will be logger dot. Let's create a debug message for now. We'll say a job goal available dot job goal clicked, and this one also needs a label, and as the label we'll use a text. We'll take in the job goal available, we'll take in the job goal.description, and we'll create a disabled. If for instance the job goal available equals false, then we will disable this one. And the scroll view will have a frame with a height and a width. The height will be 100 and the alignment will be leading. And in the preview we can add a ViewModel. This will be an empty ViewModel, and the submenu state will be a constant value of build. And let's see. Wait a sec. This action should be in a closure. Okay. I think that if we go and show the canvas, we have our two buttons, and that's disabled because there are in this empty view models no items anywhere, but at least it's able to get out all the jobs that we want to. So let's try hooking this up into our actual GUI. So we have a submenu state. We also need to keep track of that one here as well. So we'll create a state, submenu state, and this will be a submenu state, and we will default to none. Then we have our selected entity, our spacer, and we have our sort of button bottom status bar here. On top of this one we will create a new H tag, and this one will have a button, and the action will be Let's start by logging a debug message. We'll say build menu clicked, and this one will set the submenu state to build, and the label will be text. So we'll call this menu build, and we'll say, well, this one is only available, so it's disabled if for some reason the submenu state equals to build. So we've already clicked it, and then we have another spacer to make sure this aligns to the left. So I think if we run this, we should see some behavior. So we have our menu here. You can click build, and it gets disabled now because the submenu state gets changed. We get a value here that we click the build menu. Let's format this one a bit more, so we'll give it some padding, and we'll give it a background color. Just like the other ones, blend modes. Let's also add the submenu. The submenu will appear above the list of various menus you can choose in the bottom. So again, let's create an H tag, and if the submenu state equals build, then we show the build menu. We pass in the ViewModel, and we bind our submenu state variable here, so we can actually dismiss it as well at a later time. Again, we create a spacer so it gets a shift to the left, and again we give it some padding and the same background. So the color of gray, blend mode darken, and this should be runnable right now. So let's click build. Now we have our subtiles, and we can click those and click these. But and it's showing that what it's doing, but nothing more is happening because the build menu doesn't is only outputting a message so far. So let's get back into our build menu, and instead of just this clicked, let's set the submenu state to none. So this way we can also dismiss the menu. So we click build, we choose something, and then it gets dismissed. So that's working. The only thing left here is to take our ViewModel and set our current job call to the job call available job call. And this will make it so that once we choose, we choose one, the variable current job call will be set. We now need to make sure that we also call the finish selection at some point in time to make sure that we finalize the selection and create the actual job. And to do that, we will go into our game scene. And where is it? Let's go into a game scene, and we'll take the touch up. The touch up method, that one is also called by the mouse up method. That's basically when you release the mouse. We take the ViewModel and we call the finish selection function. And if we run this one, we build, we change the tile to floor, and we click a tile. And something starts happening now. It takes a bit of time before you can actually see it, because it first needs to pick up some items. Let's try the other one. So change the tile to wall, starts building, and we can see the wall. Let's try again. So create another floor, and we can see that what it's all doing to create the floor. Create another wall. You can see the worker working to create a wall. So finally we were able to actually queue jobs in the world, meaning that we can now finally issue commands to our workers in a sort of indirect builder-like way. However, you can imagine that building out a room one tile at a time can become very tedious. So next time we will implement box selecting, meaning that you can sort of draw out an entire room and queue up all the jobs needed to, for instance, build the floors or the walls. So stay tuned for that one, and for now, thanks very much for watching and have a good day.